Hey everyone, and welcome to the Deep Dive. We're going to take a deep dive into the world of API patterns today.
APIs are really interesting.
You know those unsung heroes that connect all the apps and services that we use every day?
Yeah, it's amazing how often we interact with APIs without even realizing it.
Right.
They really are the backbone behind our digital lives,
Yeah, they are.
enabling everything from online shopping to streaming our favorite shows.
Yeah, and in this deep dive, we're going to explore 5 key API patterns.
Okay.
RESTful APIs, Web APIs, WebSockets, gRPC, and GraphQL.
Sounds good.
Each one has its own strengths and ideal use cases, kind of like choosing the right tool for the job.
Yeah, that's a great analogy.
So to kick things off, let's start with the most common pattern,
Okay.
RESTful APIs.
All right, let's unpack REST.
I know it stands for Representational State Transfer,
It does.
but what does that actually mean in
Yeah, well,
practice?
essentially, REST is an architectural style
Okay,
that relies on standard HTTP methods like getT for retrieving data, post for creating new data, poster for updating, and delete for, well, deleting.
pretty straightforward.
You can think of it like using a set of familiar verbs to interact with online resources.
Okay, so if I want to get a list of products from an online store,
Mm-hmm.
I'd use a GetT request to a specific endpoint,
Yes,
like product.
precisely.
Okay,
And a key principle of REST is statelessness.
okay,
Each request from a client to a server needs to contain all the information necessary to process it.
Okay.
So imagine sending a letter
okay.
with the complete address, the message, any necessary attachments.
Oh.
The recipient doesn't need any prior context to understand the request.
Makes sense.
Keeps things simple
Yeah.
and scalable.
Absolutely.
And that simplicity is a big reason for REST's popularity.
Yeah,
It's relatively easy to understand, implement, and it works across different programming languages.
so our source material uses a bookstore example.
Okay.
It mentions having an API endpoint, like
Yeah.
books. To
Yeah.
get a list of all the books, or books to get the details on a specific book using its ID,
Right.
that's pretty intuitive.
Yeah.
But what about those times when you don't need all the information about a book?
Mm-hmm.
Just a specific detail, like the title or the author.
Yeah.
Wouldn't that be inefficient?
You've hit upon one of the potential drawbacks of REST,
Okay.
overfetching.
Overfetching.
You might receive more data than you actually need, which can impact performance,
I-
especially on mobile devices with limited bandwidth.
So there are trade-offs.
There.
REST is great for its simplicity,
Yes.
but it might not be the most efficient option in every scenario.
Exactly. And that's why it's crucial to understand the strengths and limitations of each API pattern.
Okay.
So now let's broaden our perspective
Okay.
and talk about web APIs.
Okay, so how do web APIs fit into the picture?
Mm-hmm.
Are they a separate category from RESTful APIs?
Think of web API as a broader umbrella term.
Okay.
RESTful APIs are a subset of web APIs. Essentially, any API that uses HTTP protocols for communication falls under the web API umbrella.
Okay.
This includes other types like SAP APIs,
Mm-hmm.
which use XML for data exchange.
So it's all about enabling different applications to talk to each other,
Yes,
regardless of their underlying technology.
precisely.
Okay.
Web APIs break down those barriers,
Yep.
allowing developers to build interconnected systems.
And to achieve this, web APIs rely on several key components.
They do.
Endpoints act as specific URLs where you access resources.
Yes.
HTTP methods like GAT and POST define the actions that you can perform.
Mm-hmm.
Headers provide additional information about the request, and payloads carry the actual data being exchanged.
Exactly.
Our source mentions things like payment gateways and mapping services as common examples of web APIs.
Yes, and that's because web APIs are particularly well-suited for cross-platform communication
Okay.
and third-party integrations.
Gotcha.
They let developers tap into external services and enrich their own applications with valuable functionality.
Okay. I'm starting to see how these different patterns offer unique solutions to different problems.
Yeah.
So far, we've discussed RESTful APIs
Mm-hmm.
and the broader category of web APIs.
Yes.
Now, what if we need real-time communication?
Okay.
That's where WebSockets come in, right?
You got it.
Okay.
Unlike the request-response model of REST,
Right.
where each request is like a separate phone call,
Okay.
WebSockets establish a persistent connection between the client and server.
Yeah.
like having a dedicated phone line always open.
I see. So it's a continuous two-way flow of information.
It is.
Making WebSockets perfect for things like chat applications or live sports scores.
Right.
Where you need instant updates.
Exactly. Imagine you're building a collaborative design tool
Okay.
where multiple users can work on the same project simultaneously.
Yeah.
WebSockets would be essential for real-time updates,
Right.
ensuring that everyone sees the latest changes instantly.
That makes a lot of sense, but doesn't that constant connection put a lot of strain on the server?
It can.
Especially if you have many users connected at the same time.
That's a valid concern.
Yeah.
Managing persistent connections can be more complex than handling individual requests.
Right.
It requires careful server-side architecture to ensure scalability.
Yeah. Okay.
WebSockets offer incredible real-time capabilities.
Yeah.
But they might not be the most efficient solution if your application doesn't require constant updates.
So it's a trade-off.
Yeah.
You gain real-time functionality.
Yes.
But need to be mindful of the server-side implications.
Precisely. And that brings us to a pattern that's all about speed and efficiency. gRPC.
gRPC. That one sounds a bit more technical.
It does.
What's the story behind it?
gRPC stands for gRPC Remote Procedure Call.
Okay.
It's a high-performance framework developed by Google.
Right.
And it utilizes some clever techniques to achieve incredible speed.
Okay, break it down for me. What makes gRPC so fast?
2 key ingredients.
Okay.
HTTP2 and protocol buffers.
HTTP2.
Yes. HTTP2 is like upgrading from a single-lane road to a multi-lane highway.
Okay.
It allows for multiplexing,
Okay.
meaning you can send multiple requests and responses simultaneously over the same connection.
So it's like processing multiple orders at the same time?
Yes.
Without creating a bottleneck?
Exactly.
Okay.
And to further boost efficiency, gRPC uses protocol buffers, or protobuf for short.
Protobuf.
Think of protobuf as a super efficient way to package data.
Okay.
It's like compressing a file to make it smaller and faster to send.
Ah, so it's a two-pronged approach. Faster transport with HTTP2.
Yes.
And streamlined data packaging with protobuf.
Precisely.
Okay.
And this combination makes gRPC incredibly efficient, especially in microservices architectures where speed is paramount.
Gotcha.
It's like having a Formula One race car for your data communication.
Our source mentions an order management system as an example.
Okay.
You can define different methods, like creating an order or getting order details. And gRPC handles the communication seamlessly.
Yes.
But if it's so fast and efficient, why isn't everyone using gRPC?
Well,
Are there any downsides?
one limitation is browser support.
Okay.
gRPC is primarily designed for back-end services.
Right.
And it doesn't have native support in web browsers.
Gotcha.
There are workarounds, but they add complexity.
Okay.
Also, gRPC has a steeper learning curve compared to REST.
Right.
Developers need to learn protobuf and get comfortable with the gRPC framework.
So it's not a silver bullet.
It's not.
It's a powerful tool, but it's important to consider the context and whether the added complexity is justified.
Exactly. Choosing the right API pattern is all about understanding the trade-offs and selecting the best fit for the specific needs of your application.
That makes sense.
So we've covered REST, web APIs, WebSockets, and now gRPC.
Yes.
Each pattern has its strengths and weaknesses.
Right.
Now for our final pattern, let's talk about GraphQL.
GraphQL. This one seems to be generating a lot of buzz lately.
It is.
What's all the hype about?
GraphQL is a query language for APIs, developed by Facebook to address some of the limitations of REST, particularly those issues with overfetching and underfetching we discussed earlier.
Okay, so how does GraphQL solve those problems? Does it somehow avoid fetching unnecessary data?
Exactly.
Okay.
With GraphQL, clients have fine-grained control over the data they request.
Gotcha.
Imagine you're browsing an online store.
Right.
Instead of getting a massive chunk of data about every product on the page, you can use GraphQL to request only the specific details you need.
Okay.
Like the product name, price, and image URL.
That sounds incredibly efficient.
It is.
Especially for mobile devices with limited bandwidth.
Absolutely. And to achieve this, GraphQL uses a schema to define the types of data available and the relationships between them.
Gotcha.
Think of it as a blueprint that outlines all the possible data points you can access.
I see. So the client can essentially craft a custom query.
Yes.
To request only the data they need.
Precisely.
All right.
And the server responds with exactly that data and nothing more.
Wow.
This eliminates overfetching,
Right.
reducing bandwidth usage, and improving performance.
Our source gives an example of a GraphQL query for a book. You can request the title, author's name, or any other specific field.
Right.
All in a single request.
Exactly.
That's impressive. But it sounds like implementing a GraphQL server might be more complex than a simple REST API.
You're right. GraphQL does come with its own set of complexities.
Okay.
Setting up the schema, defining data relationships, and ensuring efficient query resolution all require careful planning and execution.
So once again, it's a trade-off.
It is.
You gain incredible data efficiency and flexibility.
Yes.
But you need to be prepared for the added complexity on the server side.
Exactly. But for applications where data efficiency is paramount, like mobile apps or systems with complex data structures, GraphQL can be a game changer.
We've covered a lot of ground.
We have.
From the simplicity of REST to the real-time capabilities of WebSockets, the speed of gRPC, and the data efficiency of GraphQL. It's fascinating to see the diverse landscape of API patterns available.
It is.
But with so many options, how do we make sense of it all?
Yeah.
How do we choose the right pattern for a particular project?
Well, the source material that we're diving into today actually provides a helpful comparison table that summarizes the ideal use cases for each pattern.
No, that's handy.
Yeah, it's like a cheat sheet to guide your API decision-making.
I'm all about cheat sheets.
Yeah.
Let's take a look.
Okay.
It lists REST as being ideal for CRUD applications and microservices, which aligns perfectly with what we discussed earlier.
It does. REST's simplicity and scalability make it a solid choice for those scenarios.
Okay.
Think about building an e-commerce platform. You need to create, read, update, and delete product information. REST handles those tasks efficiently.
Makes sense. And the table also highlights web APIs for cross-platform communication and third-party integrations.
Yes, they're like the universal connectors of the API world, bridging the gaps between diverse systems.
Right.
Exactly. Imagine integrating a payment gateway into your e-commerce platform.
Okay.
A web API allows your system to securely communicate with the payment provider, regardless of the underlying technologies.
Okay, that's a great example. What about WebSockets? The table emphasizes their strengths in real-time applications.
Absolutely. WebSockets shine in scenarios where instant updates are critical.
Okay.
Think about a live chat application.
Right.
As users type messages, WebSockets enable those messages to appear on everyone's screen in real time.
Right.
Without the need for constant refreshing.
Right. That persistent connection is key for seamless real-time interaction.
It is.
Now, gRPC, as we discussed, is all about performance.
Yep.
The table confirms its suitability for high-performance scenarios, particularly in microservices communication where speed is paramount.
And it also mentions that gRPC is a good fit for systems requiring real-time data processing.
Okay.
Like IoT applications or financial trading platforms.
Right.
Imagine you're building a stock trading platform.
Okay.
Every millisecond counts.
Yeah.
gRPC's efficiency can be the difference between executing a trade at the optimal price and missing out on a profitable opportunity.
Wow, that's a powerful example. So gRPC isn't just about speed.
No.
It's about handling large volumes of data in real time with minimal latency.
Precisely. And lastly, we have GraphQL, which the table identifies as being ideal for mobile and web apps where bandwidth is a concern, as well as for applications with complex data structures.
That aligns perfectly with our understanding of GraphQL's ability to let clients request only the specific data they need.
Yes.
Minimizing overfetching and reducing bandwidth usage.
Imagine browsing a social media feed on your phone. GraphQL allows the app to fetch only the essential data for the posts currently visible on your screen.
Right.
Ensuring a smooth and responsive experience even on a limited data connection.
This comparison table is incredibly helpful in clarifying when to use each pattern.
It is.
But I'm curious, why is it so important for people to understand these differences? Is this just relevant for developers, or does it have broader implications?
That's a great question. You see, in today's increasingly digital world, APIs are no longer confined to the realm of software engineering.
Right.
Business leaders, product managers, designers, even everyday consumers can benefit from understanding the basics of APIs and the different patterns that exist.
So it's about having a broader awareness of how different systems communicate and exchange data.
Exactly.
It's like understanding the language of the digital world.
For example, let's say you're a product manager responsible for a mobile app.
Okay.
Knowing the benefits of GraphQL's data efficiency could influence your technology choices.
Right.
And ultimately lead to a better user experience.
Or if you're a business leader, evaluating a potential tech partner, understanding whether they're using REST or gRPC for their API, can provide insights into their system's performance and scalability.
Precisely, having this knowledge empowers you to ask the right questions, make informed decisions, and ultimately contribute to creating better products and experiences. It's about understanding the invisible forces that power the digital world around us.
It's like having a secret decoder ring for the internet.
I love that analogy. It's about demystifying the technology that shapes our lives. And that understanding can be a real advantage in a world where digital literacy is increasingly important.
Absolutely. So for all of you listening, take this knowledge and explore. Think about the apps you use daily. Can you spot the API patterns at play? Do they involve real-time updates? Are they handling massive amounts of data? These clues can help you identify the underlying patterns.
It's like a fun little detective game.
It is.
Put on your API detective hats and see what you can discover.
All right, before we wrap up this deep dive into API patterns, I have one final thought-provoking question for you to ponder. Think about your favorite apps, the ones you use every single day. Which API patterns do you think they might be using behind the scenes, and why?
That's a great question to consider. It really encourages you to apply what we've learned to the real world. Let's take some examples. If you're a social media enthusiast, chances are your favorite app relies heavily on GraphQL for its dynamic newsfeed and personalized recommendations. It needs to handle massive amounts of data efficiently and allow for flexible queries to deliver a personalized experience.
That makes sense. GraphQL's ability to fetch specific data points without overfetching seems like a perfect fit for a data-heavy application.
It is.
It's like a social media platform.
Exactly. Or think about a ride-sharing app like Uber or Lyft.
Real-time location updates are crucial for both drivers and passengers. It's highly likely they're utilizing WebSockets to enable that seamless two-way communication.
You need that constant connection to track the driver's location. Update the estimated arrival time and send notifications. WebSockets make that whole experience smooth and interactive.
Precisely. And let's not forget about online gaming. Imagine playing a fast-paced multiplayer game. Latency can make or break the experience. Game developers likely leverage gRPC for its speed and efficiency to ensure that every action, every move is transmitted and processed with minimal delay.
That's a great example of where gRPC's performance advantages really shine.
They do.
It's fascinating to think about how these API patterns are working behind the scenes to power the experiences we take for granted.
It really is. And remember, an app might even use a combination of different patterns.
For example, a social media app might use GraphQL for its main feed. WebSockets for real-time chat features. And REST for simpler actions like updating profile information.
So it's not always a one-size-fits-all situation.
It's not.
Developers choose the best tool for each specific task. Often combining multiple patterns to create a robust and efficient system.
Exactly. And that's why understanding the strengths and weaknesses of each pattern is so valuable. It gives you a deeper appreciation for the complexity and ingenuity behind the apps and services you use every day.
Well said. And on that note, we've reached the end of our deep dive into API patterns.
We have.
We hope you've enjoyed this journey into the world of APIs.
I hope so.
And gained a better understanding of how these invisible connectors shape our digital lives.
Yes, me too.
Remember, APIs are everywhere.
They are?
Powering countless experiences. From the mundane to the extraordinary. Keep exploring, keep asking questions. And keep diving deep into the world of knowledge.
Couldn't agree more.
Until next time, happy API hunting.